Okay, section 5.8. I'll give you a moment to copy this problem down. Yeah, I haven't started talking yet, Nabil. I'm just letting people copy things down. All right, no problem. Okay, and just a reminder, class, the extensions now in WebAssign for the assignments up through the assignment that was due today, and it's going to include the one that's due this Thursday. The extensions should last until this Friday, September 18th. Okay. And for some of the earlier assignments, the earlier ones from the first week or so of the course, if you took an extension for those assignments, the first extension will not last until this Friday, September 18th. But there will be an option for you to take a second extension, and that will get you to that will last until this Friday, September 18th. Okay, so we want to use integral tables to help us evaluate this integral. And what's the first thing that we have to do? What's the first thing that we're going to need to do here? I mean, we don't even really need to even look at an integral table to know that we have to do something. But I'll tell you what, go ahead and look at the integral tables and try to find something that's going to work. And so Rodrigo's right. We know we're going to have to make a substitution. Okay. And what, let's see, Kahindi thinks it might be formula 24. That might be the one. That's right. Let's see here. Hold on. Let's see. Formula 24. So you all have your, well, you know, you're in the right neighborhood, Kahindi. You're in the right neighborhood. So I'm not saying it's formula 24, but based on those formulas that are in that sector where formula 24 is, you know you're going to have to make a substitution. So what substitution would we make? Okay, maybe it's 23, but you're in the right ballpark. But now, before we fix on a formula, based on the formulas in that sector, so what I'm doing is, hold on here, one moment. Okay, Tina, you're right. What I'm doing is I'm looking at the formulas, and Kahindi, as well as many of you, I'm sure, are focusing on this sector of the table. But whether you're using formula 23 or 24, you know you're going to have to let u equal, as Rodrigo said, the log of 3x. Okay, I mean, we're going to have to do that. So let's go ahead and do that. So let me bring this back here. We're going to let u equal the log of 3x. Okay. And when we let u equal the log of 3x, du then would be 1 over x dx. So, you know, generally, like when I started you off with substitutions, I would say du dx. And so, you know, you'd have, by the chain rule, 1 over 3x times 3. And so therefore du is equal to 1 over 3x times 3 times dx. And so du is dx. Okay. So I actually think that this step here is actually a nice step to put in. But I realize you do so many of these substitutions that probably you can go from u equals log of 3x just to the du equals, you know, the right side. But now look what happened. Look what happened. We're replacing the log of 3x here with u. And then the dx over x is going to be replaced with du. So it turns out that that's right, Colum, that it's actually going to be formula 21 that's going to be right. So the reason I'm doing this problem with you is because when you look in the table of integrals, you should really think about, like, okay, like Kendi thought maybe it's formula 24 or 23. Well, he was in the right ballpark for sure. But then don't though think that, oh, it must be that formula. Based on the formula, that sector you're in, you know the substitution that you're going to have to make. And then do the substitution, and then that will tell you then, when you rewrite the integral, that will tell you then, oh, okay, this is the integral rewritten this way. Now I know what formula I need to use. And it turns out formula 21 is going to be the formula. When you do these table of integral problems, you don't want to do too many steps at once. You know, there are occasionally there are cases where you'll you know, be able to apply the formula directly, but many times you're going to have to do a substitution first before you finally decide on which formula is right. Not Nell, good question.
Okay, so whenever you do problems like this where you have to use the table of integrals as a reference, should we do the substitution and then decide which one to use, kind of like what we did now?
Well, yes, but the thing is, in order to do the substitution, you often have to think about what formula you want to try using. So even though, and I appreciate Kendi, he offered like formula 23, or it was formula 24 was his first guess. It turns out that isn't the right formula, but it was in the ballpark, and so he knew that we had to let u equal the log of 3x. So getting in the right ballpark tells you oftentimes what your substitution is. I think you should refer to the table first to find the ballpark area, you know, the sector of formulas. You know, try to find formula that you think is going to work. That'll give you a hint as to what substitution you need to make. Make the substitution then, and then when you get your newly rewritten integral in terms of u, then that tells you what formula finally you need to use. And in this case, it's formula 21.
Okay.
Okay, good question, not now. Good. For some reason, these problems, and I've taught calculus to a number of times, section 5.8 seems to be difficult for some students. But you don't want it to be difficult, so I'm giving you some, trying to give you some good advice. So Kahindi says, what would happen if we solve the problem with the wrong formula? Kahindi, a good question. I've never seen that happen. Anytime a student uses the wrong formula, they get the wrong answer. That's been my experience. That would be a first if you got it right with the wrong formula. Good question. All right. Are there any other questions then? Okay. Well, now what do we what do we need to do? We're at this step here. We apply the formula to get the formula 21 to get the antiderivative. And you notice that I write 21 with a circle above it right as I'm applying the formula. So when you show your work in WebAssign for your exam, I will want to see that. I want to know what formula you're using. I need to know that. It's part of the problem, part of showing your work. But now we have this antiderivative. What do we do next? Is this the final answer? Is the integral equal to u2 times the square root of 4 squared plus u squared plus 4 squared over 2 times the log of u plus, oh, okay, Pipper's saying substitute back in with the log of 3x. That's good. That's good. So that's what we're going to do. And then this will be your final answer. All right, I'll give you a moment to copy that down.
Professor.
Okay. So yes, not no. Sorry. Yes. Question.
So I pretty much get the final answer, but I'm just, oh, actually, never mind. I got it.
Okay. And Tina asked, I think I might have had my thing off, my volume off. But it's on now. So notation is important for your exams, for your work, and for the exams also. So sometimes students will say something equals something when they're not equal to each other. So you want to be just careful when you use the equal sign. And I always like to use the integral I as my integral, just because then I don't got to rewrite the integral all the time. And it was helpful also for that section 5.6 integration by parts problem, where you had to add the I terms to both sides. So, but every people do have their own styles. And okay, are there any questions before we move on here? Was this problem helpful? I was debating about whether to do this one with you or not. How many found this one helpful? Sort of just taking a little survey. Okay, Michael liked it. Wonderful, wonderful. All right. Well, let's move on. Okay, take a moment to copy this problem down. Okay, so yes, not now. You're good. Okay, so this one, we want to find the integral of 5 times the arc cosine of the square root of x. And incidentally, we know that arc cosine can be re-expressed this way. Well, hold on. Let's try it again. This is the arc cosine. Okay, so go ahead in the table and try to find the formula zone for this particular thing. All right, Tina's looking at formula 88. Natnell's looking at formula 91. Okay, and I can tell you that one of you will be right. One of you will be right. Okay, so let's go to the solution here in the beginning. First of all, I factor out to 5. And Tina and Natnell have identified two formulas. And we need to figure out which is the correct one, to use. Okay. We need to figure out which is the correct one to use. Now, the thing is, here you have the arc cosine of the square root of x dx. In formula 88, you have the arc cosine of u du. What are we going to have to do for our integral here? Well, Does the integral exactly equal formula 88 or 91? Does it equal it exactly? No. And Xiong's right. We need to do a substitution. Okay, so what would the substitution be? What substitution are we going to need to make here? The square root of x. That's absolutely right. Very good, Shilong. Very good, not now. Well, if you let u equal the square root of x, then there's no way you're going to end up with formula 88. Okay, it's going to be more complicated than formula 88. Okay, so 91 is more than like it's going to be the right one likely to use. Okay, so formula 88 is not an option since our integrand is the arc cosine of square root of x, not cosine of x. Okay, or not, I should say, arc cosine of x. Okay. This is really, I hope, you know, I want section 8.8 to be fun for you. Okay. I want it to be, how many does section 5.8 scare them a little bit? It's a little bit scary. How many are a little bit nervous about section 5.8? Oh, uh-oh, Candace is, okay. All right. And not Nell. Well, and I understand that. So, you know, my goal is to help you be more comfortable. Very good, Adriana. A little bit. Okay. All right. Esther likes section 5.7 more. Okay. Okay. All right. So now let's go ahead and get to the substitution. I'm going to move to the next page, if that's okay. Okay. So we're going to let u equal x to the half. Because, you know, x to the half, remember, is the same as the square root of x. Then du dx is 1/2 times x to the negative half. Du then, if we get du alone, which we want to do, because see, we need to find an expression for dx here. Got to figure out what I mean, we know x to the half. We know x to the half is going to be equal to u, but we need to figure out what dx is. What's that going to be? So du dx is 1/2 times x to the negative half by the power rule. Du then is therefore 1/2 times x to the negative half dx. But remember, we want to get the dx by itself. So we don't want the 1/2 times x to the negative half on the right side. Therefore, I'll multiply by 2 times x to the half. The 2 and the 1/2, when you multiply, equals 1. And x to the half times x to the negative half equals x to the 0th power, which equals 1. And so therefore, the entire, by multiplying through the equation by 2x to the half power, this entire right side becomes dx. But of course, if we multiply, but the 2 times x to the half on the left side, well, x to the half, remember, is equal to u. So therefore, dx equals 2 du. And so the integral is going to be 5 times the antiderivative of arc cosine of u times 2u du. And therefore, it turns out that formula 91 was going to be the right one to use. So this is a problem where really you have to make a substitution. Well, you have to make it to be sure, right? I mean, well, to figure out which of the formulas is right. And it was like the previous one. Okay, and so now let me see, what formula did we use here? It was formula 91, right? So right, so I should have a 91 here, circled, because I'm using that formula. And then, of course, we're going to put back in what the u was. U was equal to square root of x. Okay, are there any questions so far?
I have a question.
Yes, not now.
So right before we go to using 91, like how did you get the u cosine of -1?
Oh, I took the 2 and brought it out and multiplied it by the 5 and got a 10.
Okay.
Okay, good question. Are there any other good questions? Okay, so now I'm at this final answer for my integral, but you know, it isn't really, in my view, the final answer. I mean, I wouldn't want to type that in WebAssign. I want to simplify that a little bit, right? I want to simplify that. We want simplified answers. Okay, so let's go ahead. That's important for the exam, right? To have simplified answers. So I'm gonna, the square root of x squared, this here will become an x. And I got the product of 2 square roots. So I can write that as the square root of the product. Okay, and so we can write the integral and get it in a really nice form. Really nice simplified form. And then we get our final answer. Move that up a little bit. Yes, not now. Back to the previous page. Okay. Yes. Hold on. We'll be right back on this class page. Yeah, you had a question from here.
How did you get the 2u squared minus 1 over the 4?
This is formula 91. This is formula 91.
I see. Okay.
That's why that's why not now. I mean, actually a good question. I put the 91 over the equal sign there to tell us we're using formula 91. Good question. Okay. So you're a long way from calculus 1 here, right? I think these antiderivatives are a little more complicated, but you have more knowledge. See, so you're how many think this is like the most beautiful stuff they've ever seen? No? Oh my goodness. Well, I hope Kahindi and Tina eventually, maybe you'll change your minds on that, but we'll see. All right. All right. Okay, are there any other questions before we move on here? Okay, I'll stop the recording.